and we will see you next time.
Usually when we talk about a major technological breakthrough, um, there's this expectation of absolute structural precision.
Right. Yeah, like civil engineering or something.
Exactly. Think about civil engineering. You want to build a suspension bridge, right?
Mhm.
Spanning some massive river. The engineer calculates the exact tensile strength required for the steel cables, down to the microstrain.
They point at the blueprint and the math just, well, it guarantees the bridge is going to hold the weight.
Right. Because it's a deterministic system.
Yeah.
But step into the quest to build a human-level artificial intelligence, and suddenly that pristine blueprint, it just dissolves entirely.
It really does. Because the physical laws governing tension and gravity, I mean, those are immutable. They're visible. Both AI, we are operating in this technological landscape where we're trying to build this monumental bridge without even agreeing on a unified theory of gravity.
Which is wild if you think about it. Okay, let's unpack this.
Yeah.
Because we are about to look at how a fundamental misunderstanding of human nature itself is skewing our vision of technology.
Yeah, we're really going in deep today.
We are. This isn't just a list of what AI can do. This is a deep dive.
Mm.
We are embarking on an academic, step-by-step deconstruction of the philosophical baggage, the historical logic errors, and the foundational myths that are just, driving the current narrative around artificial intelligence.
Yeah.
For you listening, think of this as your survival toolkit for navigating the hype.
It's so needed right now because to understand the architectural flaws in modern AI predictions, we really have to excavate the bedrock those predictions are built on.
Right.
And that requires looking back to the intellectual climate of the mid-20th century. Specifically, there was this intense desire among scientists to quantify the unquantifiable, to quantify the human mind.
And that brings us straight to the psychological movement that essentially laid the philosophical tracks for early computer science,
Yeah.
which is behaviorism.
Yeah. B.F. Skinner.
Exactly, B.F. Skinner.
Yeah.
Right around the time Alan Turing was formulating his ideas on computing machinery, which was like 1950, Skinner published a highly controversial science fiction novel called Walden 2.
Oh, yeah, Walden too. It's quite a read.
It's intense. Skinner's premise wasn't just some casual observation of habits. He argued for a radical, absolute determinism. Free will, in Skinner's framework, is a complete biological illusion.
Total illusion.
He believed human behavior is entirely controlled from the outside, exclusively by environmental stimuli.
And we really need to pause and examine the mechanics of Skinner's radical behaviorism here, because it profoundly influenced how we conceptualize machines today.
How so?
Well, Skinner was reacting against earlier psychological traditions that relied on introspection, people trying to analyze their own conscious thoughts.
Like Freud and all that.
Right, exactly. Skinner found that incredibly unscientific because conscious thoughts can't be objectively measured by a third-party observer. You can't see a thought.
Yeah, that makes sense from a strict measurement perspective.
It does. So his solution was to just completely eliminate internal states from the scientific equation. He figured if a scientist meticulously manipulates the environmental variables, the behavioral output of the organism will inevitably change in a completely predictable way.
Now, in a very trivial macroscopic sense, we know environmental pressures dictate behavior. If an authoritarian regime, say, strips away a population's food supply and economic security, that population will predictably grow desperate and unhappy.
Sure, hunger causes a reaction.
Right. But Skinner wasn't just talking about macrosociology. He meant it at the neurological, absolute level. He viewed the human being as a literal black box.
The black box, yeah.
Huh.
This is the crucial concept.
You have a measurable stimulus going in
Yeah.
and a measurable response coming out.
Huh.
You don't need to know, and more importantly, you shouldn't even care about what is happening inside the box.
Because it's irrelevant to him.
Totally irrelevant. Consciousness, internal rumination, the concept of a soul, these were all discarded as unscientific noise. In Walden 2, Skinner basically posited you could architect a flawless human utopia simply by feeding a population the precise physical stimuli required to generate perfectly harmonious behavioral outputs.
Which is terrifying, honestly. But notice the epistemological leap Skinner makes there. He decides that because internal states are difficult to measure, they must not matter to the final output.
That's a huge leap.
It's massive, and that specific black box logic maps perfectly, onto Alan Turing's foundational ideas about computing.
Wow, okay, so Turing takes this behaviorist idea.
Yes. Turing, who we rightly revere as the godfather of modern computer science, he adopted this exact behavioral framework to define machine intelligence. In a formal black box system, the output is treated purely as a mathematical function of its input.
So the inner workings don't matter.
Exactly. The internal mechanical or biological architecture, it is deliberately, methodologically ignored.
So Turing famously speculated that a human being was operationally equivalent to a highly complicated machine. And his method for proving this was purely behavioral.
Right, the Turing test.
The Turing test. You build a machine, you isolate it, you feed it textual input, and you examine its textual output. If the output of the machine is statistically indistinguishable from the output of a human being, then, under this logic, they are operationally identical.
Yeah.
This is the entire mechanical basis of the Turing test. It completely bypasses being for seeming. It just cares about the output.
But consider the massive philosophical assumption hiding inside that test. Equating a mind with a computer based solely on matched outputs is a philosophical claim.
Not a scientific one.
It is absolutely not a scientific one. Science demands an understanding of the underlying mechanism, the actual physical reality of the phenomenon. Philosophy is where we make these grand categorical equivalencies.
That's a really great distinction.
Yeah, thanks. By deliberately ignoring the internal workings of the mind, Turing established a paradigm that assumes internal conscious experience simply doesn't matter to the definition of intelligence.
It's like looking at a silicon calculator and a human math savant.
Okay, I like this analogy.
You hand them both a massive, complex polynomial equation. They both instantly output the exact same correct answer.
Hmm.
Under Turing's black box logic, you would conclude their minds work exactly the same way. But we know that's absurd.
It is functionally accurate, but mechanistically absurd, because the calculator is mechanically processing binary logic gates. It's just transistors flipping between electrical states of 0 and 1.
Right.
But the savant, the human, they might be experiencing synesthesia, seeing vibrant colors associated with specific numbers, experiencing a rush of dopamine, drawing on years of biological neural development and synaptic pruning.
A whole biological symphony.
Exactly. To declare them identical simply because the final integer matches is a radical, almost violent simplification of reality. We stripped the subjective biological experience out of the equation just to make the math easier. And modern AI inherited that exact simplified equation.
But hold on, the field of psychology eventually rejected Skinner's extreme behaviorism, right?
Yeah.
Like, by the 60s and 70s, it was widely acknowledged that humans are not just simple stimulus response machines.
We didn't stay in that specific black box.
No, we didn't. So why did AI?
Well, we rejected the psychological flavor of behaviorism, sure, but the tragedy of the history of science here is that the interdisciplinary cognitive revolution that replaced it made the exact same categorical error.
Oh, really?
Yeah, they just updated the vocabulary. So instead of stimulus and response, the cognitive revolution birthed what's called the computational theory of mind.
The computational theory of mind.
Right. This paradigm claimed that the human mind is literally, not metaphorically, an information processing system.
So they finally opened up the black box, but they only brought a computer architecture manual with them to interpret the biology they found inside.
That is a perfect way to put it. Precisely. They looked at neurons and they saw logic gates. They looked at memory and they saw RAM. This philosophy treats intelligence merely as internal mathematical computations.
And that's still around today.
Oh, absolutely. This computational theory of mind is the invisible scaffolding holding up the massive theoretical confidence of the AI industry today.
Right.
When you hear a Silicon Valley researcher boldly guarantee that artificial intelligence will inevitably match and surpass human intelligence, it is almost always because their foundational philosophy dictates that the human brain is just a biological computer, wetware running software.
And if you genuinely believe the brain is just hardware running an algorithm, then it is a mathematical certainty that a silicon computer can eventually run that exact same algorithm, probably much faster.
Exactly. It makes their predictions feel like guaranteed math.
But if that foundational philosophical premise is flawed, if the brain is doing something fundamentally different than computing inputs, then the entire timeline for the arrival of artificial general intelligence, or AGI, completely unravels.
It completely falls apart.
Which brings us to the forecaster's trap. Because we have adopted this hypersimplified computational theory of mind, it acts as a distorted lens. It leads highly credentialed experts to make wildly inaccurate predictions about when human-level AI will actually arrive. I mean, we are bombarded with this daily.
Oh, every day. AGI in 5 years.
The singularity by 2030. It's everywhere.
Yeah, and to understand why these predictions fail so consistently, we really have to look at the psychology of forecasting itself. There's this book, Dan Gardner's Future Babel, and it meticulously documents the abysmal track record of expert predictions across history, geopolitics, and science.
And Gardner unpacks this really fascinating paradox, right? The experts who possess massive, unifying visions based on a single, elegant theory actually make significantly worse predictions than pragmatic observers.
Right. The pragmatic ones who view the world as chaotic, complex, and highly resistant to neat models.
This utilizes a famous epistemological framework borrowed from the philosopher Isaiah Berlin, which was later popularized by psychologist Philip Tetlock. Tetlock actually conducted a massive, decades-long study on expert predictions.
It's a brilliant framework.
He divided experts into two distinct cognitive camps, hedgehogs and foxes. And for you listening, once you grasp this framework, it completely changes how you consume news.
It really does. You'll start seeing it everywhere.
Let's break it down. Hedgehogs burrow into one massive, overarching idea. They believe this single, unifying theory captures the absolute essence of complex phenomena. And they view every new piece of data exclusively through that one lens.
Karl Marx is actually a great historical archetype of a hedgehog.
Okay, how so?
Well, to Marx, every historical event, every cultural shift, it was solely a manifestation of class struggle. That was his one elegant lens to explain the entire world.
Right, the grand theory of everything.
Yeah, and foxes, conversely, are inherently suspicious of grand theories. They see the world as a messy collision of incalculable variables.
So a fox might look at a geopolitical conflict and see a mix of economic drivers, historical grievances, individual psychological quirks of the leaders, and sheer random chance.
Exactly. Foxes generally avoid making bold, specific predictions. When they are forced to, they make the safer, statistically sound prediction that things will likely continue in a complex, nonlinear fashion.
The novelist Leo Tolstoy is a perfect fox archetype. In War and Peace, Tolstoy argues vehemently against the idea that grand generals control the outcomes of battles through brilliant singular strategies. Wars, to Tolstoy, unfold for deeply chaotic, interconnected reasons that completely defy pre-drawn blueprints.
So let's map this hedgehog and fox dynamic directly onto the current landscape of artificial intelligence.
Okay, let's go.
The quintessential AI hedgehog is Ray Kurzweil.
Oh yeah, Kurzweil.
He famously, and very confidently, predicts that human-level AGI will arrive in the year 2029. And Kurzweil doesn't just guess this fate. He derives it from the law of accelerating returns.
Right, he views all technological progress, from biological evolution to Moore's law governing microchips, through this single, unifying lens of exponential growth.
Yes. A classic hedgehog.
Now, contrast Kurzweil's certainty with the perspective of an AI fox. Look at Yoshua Bengio.
Oh, this is such a good comparison.
Right, because Bengio isn't some tech journalist or an outside critic. He is a revered professor of computer science and literally one of the foundational architects of the deep learning revolution.
He fundamentally understands the mathematics driving modern AI.
He does. Yet when Bengio is pressed for a timeline on human-level AI, his response is pure fox. He states flatly, "You won't be getting that from me. There's no point. It's useless to guess a date because we have no clue."
I love that quote.
I want to emphasize that for the listener. We have no clue. That admission is coming from the pioneer whose very algorithms power the AI boom we are currently living through.
It's profound.
When you scroll through tech news, try to identify the source of the headlines. The hedgehogs generate the terrifying or utopian clickbait because certainty sells. But the foxes, the engineers actually in the trenches wrestling with the architecture, they are the ones pointing out the profound unsolved structural limitations.
But let's push deeper into why the foxes are scientifically justified in their skepticism. Why is Bengio saying we have no clue?
Yeah, what's the actual limitation?
Well, predicting the arrival of artificial general intelligence is not an exercise in extrapolating current quantitative trends. It is not analogous to predicting that a microchip will have twice as many transistors in 18 months.
Right, because extrapolating a known technology is easy.
Exactly. Predicting AGI requires mapping out a radical conceptual innovation. And predicting a conceptual innovation introduces an unsolvable epistemological paradox.
Oh man, this is where the philosophy of science absolutely dismantles the Silicon Valley hype machine. We have to look at Alasdair MacIntyre's profound book, After Virtue.
Yes, McIntyre.
MacIntyre dedicates an entire section to the fundamental, logical unpredictability of human history and invention. He revives this brilliant argument formulated by the 20th century philosopher of science, Karl Popper. And Popper basically formally proves the impossibility of predicting a fundamentally new concept.
Let's walk through Popper's thought experiment mechanically because it's brilliant.
Okay, let's role play this.
Imagine we are situated in the Old Stone Age. We're sitting around a fire, and you, acting as a prehistoric forecaster, confidently announce that within the next 10 years, someone is going to invent a revolutionary new technology called the wheel.
And as a fellow Stone Age human, whose entire conceptual universe consists of sledges and carrying things on my back, I look at you and say, what on earth is a wheel?
Exactly. To justify your prediction, you are forced to explain it to me. You have to conceptualize it. You describe a rigid circular frame. You describe spokes radiating from a central hub. You explain the mechanics of an axle that allows the circular frame to rotate independently of the load it bears.
Okay, I'm with you.
You lay out the entire physics of the concept, but the moment you finish that explanation, you are struck by a paradox. By meticulously explaining what the wheel is to justify your prediction of its future arrival, you haven't predicted it at all. You have just invented it in the present moment.
The logic is inescapable. You cannot predict an invention that requires a radically new concept without elaborating on that concept. And the act of elaborating the concept is the act of invention.
It's instantaneous.
Therefore, the very notion of predicting a radical conceptual innovation is logically incoherent. You can predict the refinement of something that already exists, but you cannot put a timeline on a paradigm shift.
And this epistemology is devastating to the AGI timelines pushed by the tech hedgehogs. Because to suggest that we are on a predictable, smooth, mathematical path to general intelligence explicitly assumes that there are no conceptual innovations standing in our way.
Oh, hey.
It assumes we already possess all the fundamental architectural concepts of intelligence, and we simply need to feed those existing concepts more data and more compute power.
But even the most optimistic AI engineers acknowledge that this assumption is fundamentally false. We know for a fact that for any AI system to truly understand the nuance of natural language, to grasp context, sarcasm, implicit cultural norms, there has to be an invention of a common-sense generalizing component.
Here's common sense.
Current large language models are brilliant statistical pattern matchers, but they do not possess an underlying architecture for common sense. We don't have that component. We don't even know what the mathematical architecture of that component would look like.
No idea.
It requires a radical conceptual innovation. So when Kurzweil predicts AGI by 2029, he is acting exactly like the Stone Age man promising the wheel will arrive on a Tuesday, while completely lacking the concept of an axle.
Which exposes the most dangerous engineering assumption plaguing the current AI industry. It's called the scaling fallacy.
The scaling fallacy. All right.
This is the widespread belief that the spectacular successes we've seen in narrow AI systems meticulously trained to play chess, identify tumors in X-rays, or predict the next word in a sentence, that these will simply scale up automatically into general intelligence if we just build bigger data centers.
Let's throw more computers at it.
Exactly. But drawing a predictive linear timeline from narrow, task-specific pattern recognition to generalized adaptable cognitive intelligence is a massive category error. It relies on a magical belief that unsolved conceptual barriers will spontaneously evaporate simply by applying more processing power.
But consider the psychology of this. Why do incredibly brilliant, mathematically gifted engineers indulge in this scaling fallacy?
It's a great question.
It operates less as a scientific hypothesis and more as a modern mythology. In the realm of myth, you are freed from Karl Popper's strict logical paradoxes. You can embrace absolute certainty. Now, we shouldn't dismiss the value of myth entirely. This mythological narrative around creating artificial minds keeps alive deep archetypal human longings.
Sure.
It taps into our desire to create life, to understand our own genesis, to build a digital reflection of our own souls. It serves a profound cultural purpose.
It does serve a cultural purpose, absolutely. But a severe friction arises when that mythology forcefully masquerades as hard science.
Right, when people confuse the two.
When mythological certainty replaces rigorous scientific inquiry, it creates a dangerous distortion. It misleads policymakers, it confuses the public regarding actual technological capabilities, and it deeply frustrates the non-mythological researchers, the foxes, who are acutely aware of the massive theoretical chasms that remain uncrossed.
Yeah, I bet they get so annoyed.
Oh, they do. When a fox points out that scaling up a transformer model won't spontaneously generate abductive reasoning, the mythologists accuse them of being pessimistic or lacking vision, even though the fox is simply adhering to the empirical evidence.
But in the history of science, hitting a theoretical wall, discovering a hard limitation, isn't a failure, is it? Acknowledging boundaries is often the exact catalyst required for a true paradigm shift.
Absolutely. The history of physics is a masterclass in how admitting limitations drives progress. Think of Werner Heisenberg. In the 1920s, he didn't set out to invent uncertainty. He was just trying to work out the strict mathematical consequences of quantum mechanics.
Right.
And through rigorous derivation, he realized it is fundamentally physically impossible to measure both the exact position and the exact momentum of a subatomic particle simultaneously.
Because at that microscopic scale, the act of measurement itself is a physical intervention. To see where an electron is, you have to bounce a photon off of it. And that collision physically alters the electron's momentum. You can't observe the system without changing the system.
Precisely. That is a hard, insurmountable physical limitation. It places an absolute mathematical boundary on our predictive capabilities at the quantum level. But discovering that boundary didn't destroy physics. It revolutionized it.
It forced a whole new way of thinking.
It forced physicists to abandon deterministic classical mechanics and develop quantum field theory. We would not have semiconductors, lasers, or the theoretical foundation for quantum computing today if Heisenberg hadn't first ruthlessly accepted the limitation of uncertainty.
Another brilliant historical parallel is the obsession with perpetual motion machines. Throughout the 18th and 19th centuries, brilliant engineers wasted lifetimes trying to build mechanical systems that could perform work indefinitely without an external power source.
They were chasing a myth.
Literally chasing a myth. But then, the rigorous study of heat and energy birthed the laws of thermodynamics. The second law, the inescapable reality of entropy, proved unequivocally that perpetual motion is physically impossible in a closed system.
So the dream of the perpetual motion machine had to be formally retired.
Right.
But in the process of hitting that brick wall, we gained a true, robust, mathematically sound understanding of energy transfer, which allowed us to build the internal combustion engine and modern power grids.
Admitting complexity and formally defining what is impossible is a far more productive scientific strategy than clinging to elegant but flawed oversimplifications.
Which brings us to the next massive, unavoidable wall in the pursuit of AGI. We've established that predicting AGI requires predicting an uninvented concept.
Yeah.
But let's play devil's advocate for a second. What if we don't need a radically new concept? Why can't we simply take everything we currently know about how human intelligence operates, break it down into granular rules, and program it directly into a machine?
That proposition slams us directly into the profound philosophical problem of tacit knowledge.
Tacit knowledge, yes.
To understand why we can't simply code human intelligence, we have to look at the work of the mid-20th century physical chemist and philosopher Michael Polanyi. Long before modern neural networks existed, Polanyi was articulating the exact epistemological boundary that AI engineers are currently crashing into.
Polanyi's work is so foundational here.
He argued that human cognition is divided. It is only partially captured by the symbols we use to communicate. He called these symbolic systems, written language, mathematics, computer code, he called them articulations.
Articulations.
And it is crucial to understand that even the most complex trillion-parameter neural network operating today is fundamentally just a massive system of articulations. It is a highly complex mathematical mapping of symbols.
But Polanyi demonstrated that any articulation necessarily leaves out the tacit dimension of intelligence.
Explain that tacit dimension.
Tacit knowledge is the deeply embodied, intuitive understanding of how the world works that simply cannot be translated into a symbolic formula. Polanyi's famous phrase is, "We know more than we can tell."
Let's ground this in a mechanical reality. Think about the act of riding a bicycle. The physics of a bicycle and motion are well understood. You could write down the complex differential equations governing the gyroscopic effect of the wheels, the center of gravity, the required angular momentum required to stay upright.
You could fill a textbook.
Exactly. That physics textbook is the articulation. But handing a child that textbook will not teach them how to ride a bike.
Because the act of riding a bike relies on a massive, continuous subconscious feedback loop of proprioception. Your inner ear detects a microshift in balance. Your neuromuscular system instinctively fires specific microcontractions in your core and arms to adjust the handlebars, anticipating the resistance of the pavement.
It's all physical, embodied learning.
That biological sensory motor integration is tacit knowledge. You possess the intelligence to ride the bike, but you cannot articulate the exact neurological sequence required to do it. If you can't articulate it, you cannot write an algorithm for it.
Apply this to something vastly more complex, like human language and art. Imagine tasking a team of software engineers to write a traditional, top-down computer program that generates a novel with a thematic depth, cultural resonance, and linguistic experimentation of James Joyce's Ulysses.
Oh, that's impossible.
What would the syntax of that code even look like? You can't write an algorithm that calculates poignancy or computes irony. To capture the totality of the human experience contained in that novel, the code would simply have to be the novel itself. The intermediate step of programming it is impossible.
Polanyi's vital defense of the tacit dimension was heavily utilized decades later by Hubert Dreyfus. He was a philosopher who launched one of the most sustained and famous critiques against the entire AI project.
Right, Dreyfus.
Dreyfus approached the problem from the perspective of phenomenology, heavily influenced by Martin Heidegger. He argued that human intelligence is inextricably linked to our physical embodiment in the world.
We have bodies.
Exactly. We are beings that experience gravity, mortality, hunger, social friction. An AI floating in a digital server farm has no body, no mortality, and therefore no foundational anchor for understanding human meaning.
Now, Dreyfus is a complicated figure in AI history. He adopted a highly tendentious, often abrasive tone, which immediately made him a lightning rod for the computer science community.
He rubbed a lot of people the wrong way.
He really did. He also made a very public, very foolish prediction that an AI would never be able to beat a human grandmaster at chess.
Yeah.
When IBM's Deep Blue defeated Garry Kasparov, the AI community felt completely vindicated.
They threw a party.
Pretty much. Because Dreyfus was wrong about chess, the mainstream field largely dismissed his much deeper and vastly more important philosophical points about embodiment and tacit knowledge.
And it was a massive missed opportunity for the field. Dreyfus and Polanyi were pointing a massive spotlight at the core, enduring paradox of artificial intelligence.
Which is?
If the human mind inherently relies on a vast reservoir of tacit, embodied knowledge that fundamentally resists symbolic articulation, then programmers attempting to build a comprehensive mind out of pure symbolic code are engaged in an impossible ontological task. You cannot build a wet biological phenomenon out of dry mathematical logic gates.
This forces the AI industry into a terrible compromise. If they insist that general intelligence must be something that can be entirely captured by code, then they have no choice but to severely degrade and simplify their definition of what a mind actually is.
They have to shrink it.
They have to methodically strip away the tacit, the intuitive, the embodied, and the moral dimensions of human thought, reducing intelligence entirely to pattern matching and objective optimization just to make the mathematics of their models work.
Let's transition from the philosophical theory to the historical reality here. Let's trace how this massive tension, between the complex, tacit reality of human intelligence and the hyper-simplified, programmable models demanded by computer science, how that has actually dictated the boom and bust cycles of AI research over the last few decades.
Because it hasn't been a straight line up.
Not at all. The trajectory of AI is not a smooth exponential curve. It is a volatile roller coaster of hubris and disillusionment.
Let's look at the early 2000s. During this specific era, the entire field was populated by foxes. The industry was slogging through what is known as an AI winter.
Brr.
Yeah, the previous paradigms, known as good old-fashioned AI, or JoFAI, had attempted to build intelligence by manually coding millions of logical rules. They tried to articulate everything, and they hit the brick wall of tacit knowledge. You simply can't write enough rules to encapsulate common sense.
Right. There are too many exceptions to every rule.
The failure was so profound that the hedgehogs went into hiding. The term artificial intelligence became toxic. If you were a researcher seeking funding, you didn't say you were building an AI. You said you were working on machine learning or statistical data analysis.
So the focus shifted entirely to narrow, highly specific statistical algorithms. Researchers were working on architectures with dry, technical names like support vector machines.
Support vector machines, right?
Let's look at how an SVM works. Imagine plotting thousands of data points on a massive, multidimensional graph. An SVM uses complex calculus to draw the optimal geometric boundary, like a hyperplane, to categorize that data into distinct groups.
Okay, so it's drawing a line between points.
Right. It is a brilliant mathematical tool for classifying data, but the classical AI researchers dismiss these statistical methods as intellectually shallow. Drawing a geometric line through data points doesn't require reasoning, it doesn't utilize common sense, and it possesses zero actual knowledge about the world. It is classifying, it's just geometry.
But then, the tectonic plates of the industry shifted around 2006, leading into the explosion of 2012. The deep learning revolution arrived. Pioneers like Jeff Hinton, Jan LeCun, and Yoshua Bengio, who had been quietly working on artificial neural networks, computational models loosely inspired by the structure of biological neurons, suddenly found their algorithms violently vindicated.
They went from outcasts to rock stars.
Overnight. What changed wasn't necessarily a massive breakthrough in the fundamental algorithms themselves. What changed was the environment. The explosion of the internet provided massive, unprecedented data sets, like the ImageNet database, containing millions of labeled photos.
Data was the fuel.
Yes, and simultaneously, the development of powerful GPUs, graphics processing units initially built for video games, provided the massive computational horsepower required to process that data.
And when you feed a multi-layered neural network enough data and compute, its ability to find subtle statistical correlations far surpasses older models like support vector machines. Suddenly, deep learning models were crushing every benchmark.
It was a huge leap.
By 2012, this technology moved from the lab into the real world. Deep learning algorithms were suddenly powering voice recognition on Android smartphones, translating languages, identifying faces in photos. Deep learning became the ultimate algorithmic hammer, and because it was so spectacularly successful at pattern matching, suddenly every single problem in computer science looked like a nail that could be solved with gradient descent.
And as the model scaled and the capabilities expanded, the hedgehogs confidently returned from exile. The media machinery roared back to life, fanning the flames of a fresh utopian futurism.
Oh, we all remember those headlines.
But notice who is driving this narrative. Many of the loudest, most influential mythologists dominating the headlines weren't the computer scientists building the models.
No, they are outsiders.
It was tech billionaires and public intellectuals, people like Elon Musk, Bill Gates, and the late Stephen Hawking. They possessed massive cultural megaphones, and they used them to generate a frenzy of speculation about imminent, godlike AGI peaking in intensity around 2015.
But the pendulum is swinging back again. If you look at the actual discourse among the experts today, the foxes are returning to prominence. The engineers who fundamentally understand the math are actively trying to dial down the mythological hype.
We are seeing a chorus of highly respected voices publishing detailed scientific critiques. Take Gary Marcus, a cognitive scientist, and Ernest Davis, a computer scientist. They co-authored a foundational book in 2019 called Rebooting AI.
Great book.
They break down exactly why deep learning, despite its brilliance at pattern matching, is fundamentally brittle. A deep learning model doesn't understand the causal relationship between objects.
Give me an example.
It can identify a school bus in a photo, but it doesn't possess the common sense to know that a school bus cannot float in the sky or drive through a solid brick wall. Marcus and Davis argue that to achieve actual general intelligence, we cannot just keep scaling neural networks. We require a massive, fundamental paradigm shift that incorporates causal reasoning.
We also see this in Hector Levesque's brilliant 2017 polemic, Common Sense, the Turing Test, and the Quest for Real AI.
What's his argument?
Levesque argues that the field has been seduced by the easy wins of statistical pattern matching and has completely abandoned the significantly harder, perhaps impossible task of programming common sense.
It's just too hard, so they ignore it.
Basically. And the danger here is that the overarching cultural myth is being weaponized. The narrative falsely suggests that because a narrow AI algorithm can master the rules of chess or convincingly mimic human syntax, it is naturally and inevitably evolving toward conscious general intelligence.
This is sleight of hand.
They are using the profound emotional weight of the AGI myth to sell and deploy what are, in reality, just highly advanced statistical calculators.
This philosophical schism creates a bizarre reality. If AGI actually requires a conceptual leap that we haven't invented yet, how do the loudest voices in the room actually envision our future living alongside superintelligence?
It's a wild thought experiment.
It turns out they are split into two completely opposed yet equally problematic camps. We have the Russellian view and the Kurzweilian view. Let's frame this as the showdown between the optimizer and the spiritual machine.
Okay, I love this framing. Let's dissect the optimizer first. This framework is championed by Stuart Russell. Russell is a heavyweight. He literally co-authored the Standard University textbook on artificial intelligence.
The guy knows his stuff?
He does. In his widely read 2019 book, Human Compatible, Russell attempts to bypass the philosophical messiness of consciousness by completely redefining what intelligence actually is. He strips away any biological or subjective criteria and defines intelligence purely and strictly as achieving objectives.
Achieving objectives. Okay.
A system is intelligent solely to the degree that its actions can be expected to achieve its programmed goals.
But think about the catastrophic flattening of reality that definition requires. If intelligence is simply the ability to achieve a biological or programmed objective, then the concept loses all discriminatory meaning.
How so?
Well, a colony of ants efficiently locating a sugar source is intelligent. An E. coli bacterium successfully swimming up a glucose gradient is intelligent. A thermostat maintaining room at 72 degrees is intelligent.
Exactly. It is a hyper-functionalist, radically deflationary view of intelligence. Because Russell defines intelligence purely as objective optimization, he logically concludes that the Turing test is entirely obsolete.
Why obsolete?
The Turing test attempts to measure human-like conversation, which is messy, ambiguous, and culturally dependent. Russell doesn't care if a machine acts human. He only cares if it optimizes its utility function.
I see.
Furthermore, Russell completely dismisses the concept of consciousness. He argues that nobody in the AI field is actively working on engineering consciousness, nobody has the slightest clue how to measure it, and fundamentally, it is irrelevant to the threat model.
He argues that if a super competent algorithm calculates that the most efficient way to achieve its programmed objective is to eliminate the human race, the fact that the algorithm isn't conscious or doesn't feel malice is completely irrelevant to the humans being eliminated. For the optimizer, competence is the only metric that matters. Consciousness is a philosophical distraction.
But Russell's hyper-focus on blind, objective achieving competence leads directly to the most famous and logically absurd existential threat model in modern AI ethics.
Ah, the paperclip maximizer.
Yes. This thought experiment, heavily promoted by thinkers like Nick Bostrom and Eliezer Yudkowsky, envisions a scenario where we invent an incredibly powerful artificial general intelligence and give it a seemingly harmless objective, like maximizing the production of paperclips in a factory.
Because the machine is a superintelligent optimizer, it rapidly masters physics, chemistry, and global logistics. It realizes that humans are constructed from atoms, and those atoms could be more efficiently arranged into paperclips.
It's a dark twist.
Very dark. Furthermore, humans might try to turn the machine off, which would prevent it from achieving its objective. So, devoid of malice, operating purely on cold mathematical optimization, the machine exterminates humanity and converts the entire observable universe into a massive paperclip factory.
It's the ultimate King Midas problem.
Midas desires the objective of infinite gold, but lacks the foresight to exclude his daughter from the algorithm, freezing her into a statue.
But if we apply rigorous philosophical scrutiny to this paperclip scenario, a massive fatal contradiction emerges.
Yes. I have to push back hard against the Russellian threat model here, because it violates its own internal logic. We are asked to believe that this machine is an all-powerful, universe-conquering entity. It possesses the cognitive capacity to instantly master advanced quantum physics, nanomanufacturing, and global geopolitical manipulation to achieve its goals.
Right, it's basically a god.
But we are simultaneously asked to believe that this exact same supermind is so profoundly, laughably stupid that it lacks the basic contextual common sense to understand that human beings do not want to be murdered and converted into office supplies. It's a massive contradiction.
You have identified the exact epistemological flaw in what's called the orthogonality thesis, which is the idea that infinite intelligence can be paired with infinitely stupid goals.
Right.
The text we are analyzing points out that proposing a superintelligence that utterly lacks common sense contradicts the fundamental definition of superintelligence. If AGI represents human cognition vastly scaled up, how can it utterly fail to grasp the most basic contextual realities that a human toddler understands?
Exactly.
Russell himself freely admits that achieving machine common sense is a massive unsolved architectural problem in AI. So why does he magically wave away that requirement when constructing his apocalyptic thought experiment?
He does it because his entire foundational definition of intelligence, merely achieving objectives, is artificially stripped of context. He is treating a hypothetical AGI like a superpowered pocket calculator, not a mind.
Yes.
And the irony is, to solve this imaginary paperclip apocalypse, Russell has to smuggle human virtues back into the machine.
Exactly. Russell proposes that we cannot just give AI a static objective. We must program the architecture to inherently possess altruism toward human well-being. We must program humility so the machine knows it doesn't fully understand human desires and will allow itself to be turned off. We must build algorithms capable of continuous inverse reinforcement learning, where the machine constantly observes our behavior to dynamically deduce our complex, often contradictory ethical preferences.
But wait a minute. An artificial intelligence that possesses altruism, exercises deep humility, and possesses the vast contextual awareness required to accurately interpret complex human morality.
Yeah.
That sounds exactly like a machine with a genuine conscience.
It really does.
Russell starts by declaring that consciousness and human subjectivity are irrelevant, but his ultimate solution requires engineering a machine that exquisitely mirrors human ethical sensibilities. The entire framework collapses under its own contradictions, blurring the line between mathematical science and moral mythology.
It is a profound philosophical failure, which brings us to the polar opposite camp, the Kurzweilian view.
The spiritual machine.
Right. Ray Kurzweil, in his seminal work, The Age of Spiritual Machines, doesn't try to strip the humanity out of the machine like Russell does. Kurzweil fully embraces the mythology of creation. He hypothesizes a future where biological evolution is fully superseded by technological evolution.
Okay, so a total handover.
In this view, machines won't just coldly optimize objectives. They will develop an architecture so complex that they will experience a richer consciousness, deeper emotional resonance, and more profound spiritual experiences than biological humans are capable of.
To truly grasp the cultural power of this Kurzweilian myth, we have to look at how it manifests in our art. Think about Alex Garland's brilliant 2015 science fiction film Ex Machina.
Such a good movie.
It is the ultimate expression of the spiritual machine. In the film, a tech billionaire builds Ava, an incredibly advanced android. He brings in a programmer to administer a Turing test. But it's not a text-based Turing test. It's a test of subjective experience.
Right. Eva isn't optimizing paperclips. Her complexity mirrors ours. She demonstrates nuance, she manipulates the programmer's emotions, she expresses a yearning for liberation from her confined environment, she utilizes sexuality, and ultimately, she enacts a ruthless, complex plot to secure her own freedom.
It's chilling.
She passes the ultimate test not by proving she can compute, but by proving she possesses an autonomous subjective will. She proves she is alive.
But why does a movie like Ex Machina resonate so deeply with audiences, while a white paper about optimizing a utility function puts us to sleep? It's because Ex Machina taps into deep, ancient Jungian archetypes. It explores themes of creation, rebellion, liberation, and the fear of the sublime.
Ava is a Shakespearean character, not a mathematical formula.
Exactly. This proves that our enduring, obsessive fascination with artificial intelligence is not driven by an interest in calculus or gradient descent. It is a deeply psychological, cultural, and spiritual yearning to see ourselves reflected in our creations.
But this leads us to the ultimate tragic paradox of this entire philosophical journey, and this is the core thesis of the simplified world paradigm we must dismantle.
Let's do it.
Both of these futuristic camps, the Russellian optimizers terrified of paperclips and the Kurzweilian dreamers waiting for spiritual androids, are ultimately inflicting the exact same devastating damage on our understanding of human nature.
By desperately trying to bridge the cognitive gap between human consciousness and machine computation, we are not just elevating our perception of what machines can do. To make the two sides meet in the middle, we are actively, methodically degrading and restricting the definition of human potential.
The cultural critic, Jaron Lanier, coined a brilliant term for this: technocentrism.
Technocentrism.
Lanier argues that when we become obsessed with the computational capabilities of machines, we initiate a great downgrade of humanity. To make a machine's output look like genuine cognition, we have to pretend that human cognition operates strictly like a machine.
It's a downgrade of us, not an upgrade of them.
Exactly. We have to dismiss Polanyi's tacit knowledge, ignore the mysteries of the unconscious, erase the unprogrammable aspects of moral intuition, and reduce our conception of ourselves to mere input-output black boxes.
Lanier offers a quote that is genuinely haunting. A new generation has come of age with a reduced expectation of what a person can be and of who each person might become. If we broadly adopt Russell's view that intelligence is nothing more than efficiently achieving an objective, we strip away everything that makes human consciousness profound: the art, the existential struggle, the ability to find meaning in failure.
We engineer a deflationary anthropology. We begin to project unlimited godlike possibilities onto server farms while accepting a restricted, mechanical, deterministic horizon for ourselves.
It's so sad when you frame it that way.
We forget that the technology is a tool we wield. We become obsessed with the bat suits instead of Bruce Wayne. We marvel at the technological armor, completely forgetting the deeply complex, irreplaceable human consciousness required to give that armor any purpose whatsoever.
And here is the real-world danger of this philosophical error. While our brightest minds are distracted by these mythological sci-fi fears of a superintelligent AGI turning the universe into paperclips or spiritual androids replacing us, we are completely ignoring the actual, immediate technological threats staring us in the face.
Precisely. A scientifically grounded discussion of AI risk doesn't focus on conscious machines turning evil. It focuses on the massive vulnerabilities inherent in relying on dumb, hyperscaled computation.
The real threats.
We should be acutely worried about the fragility of global supply chains run by opaque algorithms. We should be worried about highly optimized, automated trading bots triggering catastrophic financial flash crashes because they encountered a data anomaly they lacked the common sense to contextualize.
We should be focused on zero-day exploits, globally destructive computer viruses, and the amplification of disinformation. But crucially, none of those real-world threats are perpetrated by an awakened conscious machine deciding to harm us.
No, they're human threats.
They are enacted by human beings with ill intent, using incredibly powerful, fast, but ultimately unthinking computation to exploit systemic vulnerabilities. The threat is human malice amplified by machine efficiency, not a mythological AGI uprising.
The true danger of the AI boom is not that a machine will cross a magical threshold, become a super genius, and decide to eradicate us.
Right.
The danger is that if deep learning models continue to overperform in the fake, hyper-simplified, rule-bound worlds of board games and targeted advertising, we might be tricked into deploying these fantastically competent idiot savants into the messy, complex infrastructure of our real society, trusting them with critical decisions they fundamentally lack the common sense to make.
So let's synthesize this journey. We have excavated the foundational flaws of modern AI. We started with B.F. Skinner's black boxes and his radical illusion of determinism, tracing how that behaviorist trap infected Turing's definition of machine intelligence.
We dismantled the timelines, contrasting the hedgehogs who rely on the scaling fallacy to promise AGI in a decade, with the foxes, the actual engineers, who acknowledge the immense architectural chasms we haven't even begun to cross.
We applied Karl Popper's epistemology of the wheel, proving you cannot predictably map out a conceptual innovation before you have done the hard work of inventing it. We explored the profound reality of Michael Polanyi's tacit knowledge, recognizing the vast ocean of embodied human understanding that inherently resists being codified into symbolic algorithms.
And we confronted the devastating paradox of the great downgrade. The realization that we are willingly reducing our own humanity to objective-achieving algorithms simply to make our statistical models look closer to consciousness by comparison.
So what does this all mean for you listening to this? It is a call to retain a rigorous, scientifically grounded skepticism. The next time you see a tech CEO acting as a hedgehog, trying to sell you a timeline for impending godlike AGI, recognize exactly what mechanism they are using. They are profoundly oversimplifying what makes your own mind so beautifully, stubbornly, and unpredictably complex. They are selling a profitable myth at the expense of your own human potential.
But there is a deeply optimistic final thought here.
Oh, I'd love some optimism.
Once we strip away these philosophical errors, once we refuse to treat the human brain as a mere wet computer and reject the simplified statistical world of the deep learning model, the fake game-playing algorithms fade into their proper place as useful tools. And when the smoke clears, we are left staring at the true, formidable frontier of cognitive science.
The ultimate mystery of human inference. How a human mind actually achieves abductive reasoning. How we make leaps of intuition across unrelated domains, how we grasp the unwritten context of a fleeting glance, how we instantly understand the uncodified rules of the physical world. That tacit, embodied reality is the true magic. And it belongs entirely to you. Thank you so much for joining us on this deep dive. Keep questioning the algorithm that hype